Hello class, and welcome to section 1.6, which is about compound inequalities. By the end of today's lesson, you will be able to write and solve compound inequalities. A compound inequality means that there are two inequalities being put together, either put together by the word and or the word or. If we're talking about the and case, we call this the intersection because it has to fit both of the requirements. So it has to work for the first inequality and for the second inequality. So both of them have to be true. When we're talking about the union, that means one or the other has to be true. They can also both be true, but it only has to be one of them. So what this looks like on the graph is if I'm graphing this first one, x is greater than 3. I'm going to go over to 3, use my open circle, and that would be going to the right because it's greater than that. If I do the second one then, we've got x is less than or equal to 7. So we go over to 7, put our closed circle there, and then we're going less than. So everything in the red works for the first inequality, everything in the green works for the second inequality. Because they're connected by and, we're only concerned about the area that works for both. So you would somehow, when you're doing a paper pencil version, you would need to highlight that. In your online book assignments, you would just simply graph between those 2 points. If we're talking about the or case, we've got, again, both of the inequalities. So this first one, x is greater than or equal to 2. So we come over to 2, put our closed dot, and it's greater than or equal to 2. And then our second one says x is less than negative 1. So we come over to negative 1, and we're getting smaller than that. So everything in the red works for the first one, everything in the green works for the second one, which means everything that's colored in works for this inequality because it's either this part or that part. So in this case, the only thing that doesn't work is what ends up in between them. Go ahead and try graphing this one on your own. When we do this, we have an and, so we have the first one and the second one, and that and area is the blue part in between. When you have compound inequalities, you might also need to solve them. So you can use that idea that we learned yesterday about solving inequalities to help you graph these. So with this first one, we've got negative 3x plus 2 is greater than negative 7. I'm going to start by subtracting 2 from both sides. So I've got negative 3x is greater than negative 9. And then I'm going to finish by dividing by negative 3 on both sides. Remember, when you divide by a negative, you need to flip the inequality sign. So we end up with x is less than 3. Then I need to solve this second part. I'm going to start by distributing there. So I've got 2x minus 4 is greater than or equal to 6. My next step is going to be to add 4 to both sides. So I end up with 2x is greater than or equal to 10. And I'm going to finish by dividing by 2 on both sides of my equation, giving me x is greater than or equal to 5. So when I come back to graph this first one, we've got x is less than 3. So we go over to 3, put our open circle, and then everything less than that is going to the left. For the second one, we've got x is greater than or equal to 5. So we come over to 5, put our closed circle, and then everything to the right of that. So that is our solution to this particular union or compound or inequality. Go ahead and try this one on your own. So after you solve using those SAD MEP steps, you end up with x is less than 4 and x is greater than negative 2, giving you this graph. Looking at and, there are 2 different ways that this could be written out. This is the first way where it doesn't actually use the word and. It's saying negative 12 is less than or equal to 7x plus 9, which is less than or equal to 16. You could break this up into the and inequality, or you can solve it all at once. If you're going to solve it all at once, the first thing we need to do is get rid of this 9. So we're going to subtract 9. We need to subtract 9 from both of the two outside quantities because negative 12 is less than that and the equation is less than 16. So we have to do it to all three parts. So we end up with negative 21 is less than or equal to 7x, which is less than 7. So again, we subtracted from all three parts. We're going to do the same thing now when we divide to get rid of that 7. We're going to divide all three pieces of this inequality by 7. So we end up with negative 3 is less than or equal to x, which is less than 1. So when we put that on the graph, we're going to come over to negative 3, and we've got our closed dot there because negative 3 is less than or equal to. And then we're going to come over to 1, and we have our open dot. Because it's an and inequality, it's in between those two pieces. X is bigger than the first one, and x is smaller than the second one. You might also see and inequalities written out with the actual word and. This is still solved the same way using those sad meat steps. So for the first one, I'm going to subtract 10 from both sides, giving me x is greater than or equal to negative 7. And then for the second one, I'm going to start by adding 10 to both sides, giving me 6x is greater than or equal to 12. And then I'm going to finish by dividing by 6 on both sides, giving me x is greater than or equal to 2. So for this first inequality, I'm going to go over to negative 7. 1, 2, 3, 4, 5, 6, negative 7. And I'm going to put my filled in circle because it's greater than or equal to, and that's going to the right. Then we have x is greater than or equal to 2, so I'm going to come over 1, 2. I've got a dot here, and again, this one I'm also going to the right. So our job now is to figure out what part actually works. So we're looking for that piece of overlap. So this piece going greater than 2 is our solution here. Go ahead and try this one on your own. After solving both of these inequalities, you get x is greater than negative 3 and x is less than or equal to negative 1. Once you graph those, we end up with that overlap area being between the 2 points. Last thing, we're going to go through a couple of word problems. This one, Enrique plans a diet for his dog Rio. Rio consumes between 510 and 540 calories per day. Write and solve an inequality to show how many treats Rio can have if she eats 1.5 servings of food. So the first thing you want to make sure you're decoding in these kind of word problems is it going to be an and or an or? In this case, it's saying between 510 and 540. We've got the word and in there telling me it's going to be an and inequality. The next piece of information I have is that it's 1.5 servings of food. So if I look at my servings of food, that's 320 calories. I want to have 1.5 servings of those. So when I do that, I end up with 480 calories. We want to figure out how many treats. So that is going to be our variable. When we set this up, our first thing is it's going to be 510 is less than or equal to, because the dog can eat 510 calories. And then we have our 480 from the food, plus 15 times we don't know how many treats, and that has to be less than or equal to 540. The reason that we have that equal to part on there is because it could equal, that is the amount of calories that she could, or the dog could eat. Then we're going to go ahead and solve this, remembering since I wrote it as one big inequality, I have to make sure to subtract from all three portions of this inequality. When I do that subtraction, I end up with 30 is less than or equal to 15x, which is less than or equal to 60. And I'm going to solve by dividing everything by 15, which is going to give me 2 is less than or equal to x, which is less than or equal to 4. So my conclusion here would be that Rio can eat between 2 to 4 treats. So you want to make sure you have that final conclusion as you are solving these problems. Go ahead and try this one on your own. So in this case, he's biking at 10 miles per hour, which gives us that 10x in the middle. He wants to go between 12 and 15 miles, dividing both by 10. We end up with him riding between 1.2 and 1.5 hours. If you converted that into hours and minutes, that is also okay. If you have questions about this or anything else from the lesson, please let me know when you get to class.